We think we know our own cosmic neighborhood, but the universe is a master of illusion. Prepare for a journey through 30 space facts that will fundamentally alter how you see the night sky. You will walk away with a collection of cosmic truths that feel more like science fiction than reality. We will uncover why the footprints on the moon might outlast humanity itself, and how a day can stretch longer than a year. What is the one fact about space that truly makes you stop and wonder? Our own moon is in a slow, silent retreat. Every single year, it drifts about 3.8 centimeters farther from Earth. That is roughly the width of two of your fingertips. This gradual departure is a cosmic tug-of-war, driven by the gravitational dance between Earth and its satellite. The moon's gravity pulls on our oceans, creating the bulges we know as tides, but Earth's rotation is faster than the moon's orbit, so our planet essentially drags that tidal bulge slightly ahead of the moon. This leading bulge, in turn, exerts a gravitational pull that gently tugs the moon forward in its orbit, pushing it just a little bit farther out. It is a delicate transfer of energy that has been happening for billions of years. In the distant past, the moon was much closer and a day on Earth was significantly shorter. As the moon continues its retreat, it will slow our planet's spin even more, making our days longer. Total solar eclipses, that breathtaking cosmic coincidence where the moon perfectly covers the sun, will eventually become a relic of the past. The moon will appear too small in our sky to completely blot out the solar disk. This slow-motion departure is a reminder that even the most seemingly permanent features of our sky are in a state of constant, graceful change. While our own moon is slowly leaving us, another world in our solar system operates on a truly alien clock. On Venus, a single day lasts longer than an entire year. Picture the strangeness of that for a moment. The time it takes for Venus to complete one full spin on its axis, which we call a day, is 243 Earth days. Yet the time it takes for Venus to travel all the way around the sun, which we call a year, is only 225 Earth days. You could celebrate your birthday there before the sun has even risen and set once. This is not the only way Venus defies convention. It also spins in the opposite direction to almost every other planet. From a hypothetical vantage point above the solar system, you would see Venus rotating clockwise, a motion we call retrograde, while the other worlds spin counterclockwise. So on Venus, the sun would rise in the west and set in the east. What could have caused such a profound reversal? Scientists believe a colossal collision in the ancient past may have literally flipped the planet upside down, leaving it spinning backwards. Another compelling theory suggests that the sun's powerful gravitational pull, combined with the thick, soupy atmosphere of Venus, created immense tidal forces that gradually slowed the planet's original spin to a crawl and then reversed its direction over billions of years. This world of crushing pressures and scorching temperatures continues to guard its oldest secrets, a slow and backward mystery right next door. Far from the orderly orbits of planets, the cosmos brews its own strange chemistry. Drifting near the center of our galaxy is an immense cloud known as Sagittarius B2. Within this colossal veil of gas and dust, astronomers have identified a truly staggering ingredient: billions upon billions of liters of vinyl alcohol. This is not the kind of alcohol you would find in a beverage, of course, but its presence is a profound clue. It tells us that the vast emptiness of space is not empty at all. It is a sprawling chemical factory operating on a scale we can barely fathom. These giant molecular clouds are the nurseries where new stars are born, and the complex molecules swirling within them are the very raw materials for planets and, potentially, life itself. Finding such a large and complex organic molecule floating freely between the stars suggests that the basic building blocks for life are not unique to planets. They are being forged in the cold, dark reaches of interstellar space and then delivered to young worlds by comets and asteroids. This cosmic cocktail of chemicals implies that the ingredients for life could be a common, widespread phenomenon throughout the galaxy, scattered by the great clouds that drift between the stars. The same cosmic clouds that brew the ingredients for life can also forge objects of unimaginable destruction. When a massive star dies, it does not go quietly. It explodes in a supernova, a blast so violent that it can outshine an entire galaxy. In the heart of that cataclysm, a neutron star is born. This is the collapsed core of the dead star, a city-sized object that packs more mass than our entire sun into a sphere only about 20 kilometers across. The physics of such an object are almost beyond belief. A single teaspoon of neutron star material, if you could somehow bring it to Earth, would weigh billions of tons. That is the weight of a mountain compressed into a tiny speck you could hold on a spoon. How is such density even possible? During the supernova, the star's own immense gravity crushes it inward with unimaginable force. Protons and electrons are forced together, merging to become neutrons. All the empty space that makes up a normal atom is squeezed out until the star becomes a solid ball of nuclear material, a single city-sized atomic nucleus. If you were to drop a marshmallow onto the surface of a neutron star, the impact would release as much energy as a hydrogen bomb. These spinning remnants are the universe's ultimate heavyweights, proving that sometimes the most incredible power is hidden within the smallest of packages. But even a neutron star's density pales before the sheer scale of another type of cosmic giant. On the surface of Mars stands Olympus Mons, the largest volcano in the entire solar system. This is not merely a mountain, it is a geological monument so vast that its base would completely cover the state of Arizona. From base to summit, Olympus Mons rises nearly 22 kilometers high, making it almost 3 times the height of Mount Everest here on Earth. Why did Mars, a planet half the size of our own, produce such an incomprehensibly massive feature? The secret lies in a fundamental difference between the two worlds. Earth has active plate tectonics. Our planet's crust is a jigsaw puzzle of shifting plates. As a volcanic hotspot pushes magma upward, the moving plate slides over it, creating a chain of volcanoes like the Hawaiian Islands, rather than one single colossal peak. Mars, however, lacks these mobile plates. Its crust is a single solid shell. For billions of years, a fixed hot spot beneath Olympus Mons kept pumping lava to the surface, layer upon layer, building a volcano in one single location without ever moving. It grew slowly and relentlessly, an unstoppable forge on a static world. If you were to stand on its summit, you would not even perceive the slope. The caldera's rim would be lost over the horizon, and you would simply feel as if you were standing on a vast, flat plain. This is the legacy of a planet that chose to build one epic masterpiece instead of many smaller creations. Beyond the known planets, a hidden giant might be silently shaping our solar system. For decades, astronomers have noticed something deeply strange about the distant, frozen objects in the Kuiper Belt, the ring of icy debris beyond Neptune. These small worlds do not orbit randomly. Instead, their paths are mysteriously clustered, all swooping around the sun while tilted at a similar angle, as if an unseen hand is hurting them. The mathematical explanation for this orbital synchrony points to one compelling possibility: the gravitational pull of a massive, undiscovered planet. This hypothetical world, often called Planet 9, is not a small rock. Scientists calculated could have up to 10 times the mass of Earth, a true giant lurking in the perpetual twilight at the edge of our cosmic neighborhood. Its orbit would be immense and highly elliptical, taking it on a lonely journey so far from the sun that a single year there could last 20,000 Earth years. Finding it, however, is a monumental challenge. At such a vast distance, it would reflect almost no sunlight, making it an incredibly faint pinprick in an ocean of black. Telescopes are scanning the predicted regions of its orbit, trying to catch a glimpse of this ghostly world. If it exists, Planet 9 would rewrite the story of our solar system's formation, suggesting our family of planets is larger and more dynamic than we ever knew. The sun holds a mystery so profound it defies our basic understanding of heat. Its visible surface, the photosphere, is a searing 5,500 degrees Celsius. Yet just above it, the wispy outer atmosphere called the corona burns at an incomprehensible 1 to 3 million degrees. This is the coronal heating problem, a puzzle that has baffled physicists for decades. How can the atmosphere be hundreds of times hotter than the surface itself? It is as if you walked away from a campfire and the air a few feet away suddenly became scorching hot instead of cooling down. The answer is not simple because the sun is a churning ball of plasma, not a solid object. One leading theory points to nanoflares. These are tiny, constant explosions happening all over the sun's surface, too small for our telescopes to see individually, but collectively releasing enormous energy. Another compelling idea involves magnetic waves. The sun's powerful magnetic field is constantly twisting and snapping, sending waves of energy rippling outwards. These waves then dump their tremendous heat into the corona, superheating it. Scientists now believe the true answer is likely a combination of these mechanisms, a constant invisible storm of magnetic activity that cooks the corona to temperatures we still struggle to fully explain. This invisible furnace is what drives the solar wind, the stream of charged particles that flows past Earth and creates our auroras. So the very mystery that confounds us is also the force that paints our polar skies with light. Silence is a profound illusion in the cosmos. We are taught that in the vacuum of space, no one can hear you scream, and this is technically true because sound as we know it requires a medium like air to travel. Yet to call space silent is to ignore a constant, invisible symphony. Space is saturated with electromagnetic radiation, ripples of energy that can be translated into sounds our ears can understand. Scientists use a process called data sonification to turn these signals into audio. The results are haunting. Jupiter's magnetosphere, a vast bubble of magnetic fields, crackles and pops with intense radio emissions as it interacts with the solar wind. It sounds like a cosmic shoreline being pounded by an endless tide of energy. Saturn's rings produce a ghostly, ethereal hiss, a whisper of countless ice particles colliding and dancing in the void. Even the tenuous plasma between stars can be heard as a low, pervasive hum. These are not sounds in the traditional sense, but they are real vibrations, the true voice of the universe translated into a frequency we can perceive. Listening to this cosmic chorus reshapes our understanding of emptiness. The void is not a still and dead place, but a vibrant arena of energetic activity, a concert hall of invisible forces singing their strange, electromagnetic songs. Even the most brilliant stars face a final, crystalline death. After a sun like our own exhausts its nuclear fuel, it does not simply vanish. It sheds its outer layers in a beautiful planetary nebula, leaving behind a hot, dense core known as a white dwarf. This Earth-sized remnant is the star's glowing ember, initially searingly hot, but destined to cool for eons. At its heart lies a secret forged under extreme pressure, a core of crystallized carbon. Imagine a sphere of solid diamond, not the size of a gemstone, but the size of an entire planet. This is the reality of white dwarf stars like PM 37093, a cosmic jewel located about 20 light-years away. Astronomers estimate its crystallized core has a mass of about 5 million trillion pounds, a diamond so vast its value is literally incalculable. This incredible transformation is the final chapter for most stars. The immense gravitational pressure inside the cooling white dwarf squeezes its carbon atoms into a rigid lattice structure, the same atomic arrangement that gives us the diamonds we treasure on Earth, but on a scale that defies all human comparison. It is a glittering tombstone, the ultimate legacy of a star that has burned out, leaving behind a permanent, crystalline monument to its former glory. The serene beauty of a diamond star gives way to a far more violent reality among the gas giants. You could never stand on Jupiter, Saturn, Uranus, or Neptune because there is no ground to stand on. These are worlds of almost pure atmosphere with no solid surface anywhere. If you tried to land on Jupiter, your descent would be a one-way trip into an endless, deepening nightmare. At first, you would fall through bands of multicolored clouds, ammonia crystals whipping past. The farther you fell, the thicker and hotter the atmosphere would become. The crushing weight of the gases above you would increase until the pressure felt like thousands of elephants standing on your chest. Long before you reached any theoretical center, the pressure would become so immense that it would fundamentally change the nature of matter itself. The hydrogen gas that makes up most of the planet will be squeezed into a liquid state, creating a planet-wide ocean of liquid hydrogen. Deeper still, the pressure forces that liquid hydrogen to behave like a metal, a swirling, electrically conductive sea unlike anything found on Earth. Your body will be vaporized, then compressed, your atoms scattered and assimilated into the planet's churning interior. This is the fate of anything that ventures too close to a gas giant, a complete and utter dissolution into a world that is more a fluid entity than a solid planet. Those silent footprints left on the lunar surface are a fossil of human ambition, and they may well outlive our entire species. On Earth, wind, water, and the slow churn of tectonic plates erase all traces of our passage in a geological blink. But the moon is a museum of stillness, with no atmosphere to speak of. There is no wind to sweep the fine lunar soil, called regolith. There is no rain to wash the impressions away. The moon's internal geological engine has long since shut down, so no volcanoes bury the sites under new rock and no quakes shift the ground. Every boot print, every delicate tread from the lunar rover, even the discarded descent stages of the landers, sit in a perfect state of suspended animation. They are exposed only to the gentle rain of micrometeorites, which will take millions upon millions of years to slowly sandblast the details away through random, pinpoint impacts. This creates a profound thought. The flags themselves, bleached white by unfiltered solar radiation, may have disintegrated, but the marks of our first tentative steps off our world could endure for eons. They are a permanent monument to a fleeting moment of courage, waiting in the silence for a future visitor to rediscover that we were once there. The silent, sun-scorched surfaces of Mercury and the moon guard a precious secret in their polar shadows. Despite blistering daytime temperatures, deep craters at their poles exist in a state of perpetual night, their floors never touched by sunlight. In these profound cold traps, temperatures can plummet to minus 200 degrees Celsius, cold enough to preserve water ice for billions of years. The discovery of this ice was a stunning revelation. We once thought of the moon as a bone-dry desert and Mercury, the closest planet to the sun, as the last place you would ever find water. Yet orbiting probes using special instruments to peer into those eternal shadows confirmed vast deposits of water ice lurking just below the surface. This ice did not form from oceans or rain, but was delivered over eons by comet and asteroid impacts, each collision splashing water across the landscape. In the sunlit areas, that water would have instantly boiled away into the vacuum, but any molecules that randomly bounced into a shadowed crater became trapped forever, accumulating into a frozen resource. This changes everything for our future in space. Water is not just for drinking, it is the key to survival and exploration. It can be split into hydrogen and oxygen to create breathable air and powerful rocket fuel. A permanent lunar base could use this local resource, mining the ice to sustain its crew and refuel spacecraft headed deeper into the solar system. Mercury, with its own icy caches, could one day serve as a distant outpost. The most inhospitable places in our inner solar system have become the most valuable, offering a cosmic oasis for humanity's next great leap. Jupiter's Great Red Spot is a storm that has witnessed centuries of history. This colossal swirling tempest is so vast that our entire planet could fit inside it, a raging vortex in the cloud tops of a giant. First observed with certainty in the 1600s, it has been churning for at least 400 years, a permanent fixture in the Jovian sky. Yet this ancient landmark is changing. For decades, astronomers have been measuring a steady and unmistakable decline. The storm is shrinking. In the late 19th century, it was estimated to be over 40,000 kilometers wide enough to swallow 3 Earths side by side. Today, it is barely large enough to hold one. The rate of this shrinkage seems to be accelerating, raising a profound question: is the Great Red Spot dying? The storm is essentially a massive anticyclone, a high-pressure system where gases spiral outward from the center. Its longevity is thought to come from its ability to absorb smaller storms, feeding on the energy of its chaotic surroundings to sustain itself. But something in that delicate balance has been disrupted. One theory suggests that the jet streams that confine and power the storm are changing, perhaps due to deeper shifts within Jupiter's fluid interior. Another possibility is that it is simply running out of smaller eddies to consume, slowly starving in plain sight. What happens if it vanishes entirely? The Great Red Spot is more than just a pretty picture. It is a fundamental feature of Jupiter's atmospheric dynamics, a massive engine of weather. Its disappearance would alter the complex banding of the planet's clouds and change the flow of the very jet streams that once sustained it. We are watching a cosmic era draw to a close, a storm that has raged since the time of telescopes first learning to see the heavens, now quietly fading away before our eyes. The fading of Jupiter's great storm reminds us that even the grandest cosmic features are temporary, yet the most primitive and ancient objects in our solar system carry a scent that has been preserved for billions of years. The Rosetta mission achieved something unprecedented. It flew alongside a comet and directly sniffed its atmosphere. The target was Comet 67P, Churyumov-Gerasimenko, a frozen relic from the solar system's dawn. As the comet neared the sun and began to warm, its icy surface sublimated, releasing gases that Rosetta's instruments could taste. The analysis revealed a chemical cocktail that was both startling and pungent. The comet's coma, the cloud of gas surrounding it, was rich with hydrogen sulfide, the same gas that gives rotten eggs their distinctive, stomach-churning odor. Mixed in was a strong presence of ammonia, which carries the sharp, acrid smell of horse urine. This was not the pristine, clean fragrance of pure ice one might imagine, but the complex and unpleasant aroma of a primordial chemistry lab. These simple molecules, frozen solid since the very beginning, are time capsules. They tell us that the building blocks of our solar system were not just rocks and dust, but a rich mixture of organic compounds. The fact that comets like 67P are thought to have delivered water and organic material to the young Earth makes this discovery deeply personal. The very ingredients that may have seeded our world with the potential for life arrive with the faint, lingering scent of a stable and a barnyard, a humble and smelly beginning for everything we know. This staggering abundance of life on our own world is a humbling cosmic fact. Right here on Earth, there are more trees than there are stars in our entire galaxy. The most robust estimates suggest our planet is home to roughly 3 trillion trees. Now look up at the Milky Way, that vast, swirling river of light. The total number of stars within it is estimated to be between 100 billion and 400 billion. Even at the highest star count, our planet still hosts several times more trees. Picture that for a moment. Every single star you see on a clear night, and every one of the countless stars you cannot see, is outnumbered by the roots and branches on our own world. This is not a statement about the size of the universe, which is incomprehensibly large, but a powerful reminder of the sheer, vibrant density of life in our own small corner. Our galaxy is mostly empty space, a vast, dark void punctuated by brilliant but isolated furnaces. Earth, by contrast, is a teeming oasis, a world so densely packed with life that its botanical citizens alone outnumber all the suns in the Milky Way. It forces a shift in perspective. We often feel small under the night sky, yet we are living on a planet of profound biological wealth, a rare and precious jewel of abundance in a galactic sea of silent light. That profound sense of life's abundance is framed by a sky that is itself a living museum. The Hubble Space Telescope does not just show us distant objects, it opens a portal to the past. Every time we gaze at a faraway galaxy, we are seeing it not as it is today, but as it was when the light now reaching our eyes began its journey across the cosmos. This is not a metaphor, it is a direct consequence of the finite speed of light. Light travels at an incredible 300,000 kilometers per second, but across the gulfs of intergalactic space, even that speed is not instantaneous. The light from our own sun takes about 8 minutes to reach us, so we see the sun as it was 8 minutes ago. Hubble pushes this principle to its absolute limit. When it observes a galaxy 10 million light years away, the light it captures has been traveling for 10 million years. We are witnessing that galaxy's ancient history, a snapshot from an era when our own human ancestors were just beginning to walk upright on the plains of Africa. Some of Hubble's deepest field images reveal galaxies whose light has been traveling for over 13 billion years, showing us infant galaxies as they appeared just a few 100 million years after the Big Bang itself. This transforms the night sky into a cosmic time machine. We are not just looking out into space, we are peering back through the eons, watching the very construction of the universe unfold in a gallery of fossilized light. The universe is a grand time machine, but our own bodies carry a direct physical link to the cosmos. Astronauts living aboard the International Space Station experience a strange and literal stretch, growing up to 3% taller during their missions. For an average person, that is an increase of about 5 centimeters, a noticeable gain in height achieved not through exercise or magic, but through the simple absence of gravity. Here on Earth, gravity constantly compresses our spines, squeezing the discs of cartilage between our vertebrae. In the microgravity of orbit, that constant downward pull vanishes. The spinal column, free from its daily burden, relaxes and expands. The spongy intervertebral discs, which act as shock absorbers, slowly soak up fluid and stretch out, causing the entire spinal column to lengthen. An astronaut might launch into space one height and within just a few days be looking down on their former self. This newfound stature, however, comes with a significant cost. The elongation of the spine stretches the muscles and ligaments in the back, which are not accustomed to this new, longer configuration. This often leads to severe back pain and a higher risk of herniated discs for crew members. The most dramatic reversal happens upon their return to Earth. As gravity reasserts its familiar pull, the spine is compressed once more. Within a few months, sometimes even just weeks, the astronaut's body returns to its original pre-flight height. That cosmic growth spurt is entirely temporary, a fleeting souvenir from a world without weight. The temporary stretching of an astronaut's spine is a gentle reminder of how alien other worlds can be, but some planets are hostile beyond anything we experience. HD 1897333b is a world where the skies rain glass. This exoplanet, located about 65 light-years away, is a gas giant locked in a scorching embrace with its star. It is so close that its year lasts just 2.2 Earth days, and one side is permanently cooked, creating temperatures that soar to a blistering 1,700 degrees Celsius. At such incredible heat, silicate particles in the upper atmosphere, the same stuff that makes up sand on our beaches, do not stay solid. They vaporize, becoming a swirling, gaseous component of the air. As these silicate-laden winds blow from the day side to the slightly cooler night side, the temperature drops just enough for the vapor to condense. It does not form soft raindrops, but hard, microscopic shards of glass. And here's where the true fury of this world is revealed. The planet is lashed by winds that scream across its surface at speeds of up to 8,700 kilometers per hour, nearly 7 times the speed of sound. These hurricane-force winds do not merely let the glass fall. They whip it sideways, scouring the atmosphere in a relentless, horizontal blizzard of razor-sharp projectiles. There is no calm, no shelter, just an endless, abrasive storm where the sky itself is a weapon. This is not a place of gentle showers, but a cauldron of extreme physics, a world sculpted by a beautiful, yet utterly deadly form of precipitation. The most frigid void of interstellar space is no match for the chill we can create in a laboratory. Right here on Earth, scientists have engineered the coldest temperatures in the known universe. Within specialized vacuum chambers, they use a web of lasers to slow atoms down, robbing them of their kinetic energy and thus their heat. They can cool matter to within a billionth of a degree above absolute zero, the theoretical point where all atomic motion ceases. That is a billion times colder than the frozen background of deep space. At these extreme temperatures, something extraordinary happens to a cloud of atoms. They cease behaving as individual particles and merge into a single unified quantum state known as a Bose-Einstein condensate. In this bizarre form of matter, atoms lose their identity, overlapping and behaving as one single superatom, a wave of matter that can be studied directly. This is not just a laboratory curiosity, it is a window into the quantum world, allowing us to probe the fundamental rules that govern reality itself. By studying how matter behaves at these ultra-cold temperatures, we gain insights into superconductivity, superfluids, and the very nature of quantum entanglement. The greatest cold in the cosmos is not found in the dark between stars, but in the brilliant light of our own lasers, revealing secrets hidden in the near absence of heat. The same cosmic violence that forges neutron stars can unleash a far greater terror from across intergalactic space. A gamma-ray burst is the single most powerful explosion in the universe since the Big Bang itself. In a matter of seconds, one of these events can release more energy than our sun will emit across its entire 10 billion-year lifetime. This is not a slow burn, but a sudden, focused detonation of pure gamma radiation, the most energetic form of light. Most bursts occur when massive stars collapse into black holes or when super-dense neutron stars merge, firing twin jets of radiation out from their poles like the beam of a cosmic lighthouse. If one of those jets were pointed directly at Earth from a relatively nearby galaxy, the consequences would be apocalyptic. The initial flash of gamma rays would be harmless to life on the surface, but it would violently rip apart the molecules in our upper atmosphere. This chemical chaos would create a thick smog of nitrogen dioxide, a brownish gas that blots out the sun and triggers a profound chemical change. It would systematically destroy the ozone layer, the fragile shield that protects all land-based life from the sun's deadly ultraviolet radiation. With that shield gone, the surface of our planet will be bathed in a sterilizing UV light. Ecosystems would collapse from the bottom up, as phytoplankton in the oceans and plants on land perish. The food web would disintegrate, leading to a global mass extinction event. The terrifying reality is that this is not science fiction. Some scientists theorize that a gamma-ray burst may have been responsible for the Ordovician extinction 440 million years ago, one of the 5 great die-offs in Earth's history. Our galaxy is vast, and such a direct hit is incredibly rare, but the universe reminds us that its most beautiful energies can also be its most deadly. Saturn's magnificent rings, those iconic bands of ice and dust, are not the ancient relics we once imagined. Recent data from the Cassini mission has revealed a stunning truth. They are cosmic newcomers, likely forming between just 10 and 100 million years ago. This means that when dinosaurs roamed the Earth, Saturn may have been a plain, unadorned planet. The evidence comes from the rings themselves. They are remarkably bright and clean. In the dusty environment of the solar system, older rings would have been darkened by a steady accumulation of cosmic soot over billions of years. The pristine ice we see tells us these structures are fresh, a temporary and dazzling feature in Saturn's long life. Their youth points to a dramatic origin, perhaps a small, icy moon that wandered too close to the giant planet. Saturn's immense gravity would have torn that moon apart, scattering its remains into a disk of brilliant debris that quickly organized into the rings we see today. Yet this beauty is fleeting. The same data suggests the rings are slowly raining down onto the planet. Micrometeorite impacts and solar radiation disturb the tiny ice particles, giving them an electrical charge that allows Saturn's magnetic field to pull them in. This ring rain is draining the equivalent of an Olympic-sized swimming pool from the rings every single day. At this rate, they may be completely gone in another 100 million years. We are living in a special cosmic moment, a narrow window in time to witness a ringed giant, a spectacle that appeared long after the dinosaurs and will vanish long before the sun grows old. Some galaxies burn out long before their time. Billions of light years away, a galactic fossil known as MAX 21291 hangs in the void, a relic from the universe's younger days. This is not a slowly fading elder, but a galaxy that lived fast and died young. It formed all of its stars in an incredibly intense burst of activity, and then abruptly it stopped. For over 10 billion years, this cosmic island has been in a state of suspended animation, a dead galaxy where no new suns are born. The mystery is not just its death, but its shape. MAX 21291 is a perfect flat disk, similar to our own spiral Milky Way. This defies everything we thought we knew. Astronomers believe that such orderly disk galaxies were always active, constantly forming new stars from their rich reserves of gas. Giant, messy, elliptical galaxies were thought to be the retired ones, the results of violent mergers that used up or blew away their star-making fuel. But this discovery shatters that simple story. How could a pristine disk galaxy simply shut down? One possibility is that something inside the galaxy, perhaps a supermassive black hole at its heart, became incredibly active. The energy from this feeding monster could have blasted the galaxy's remaining gas reservoir out into space, starving it of the raw material needed to create new stars. Another theory suggests that the gas in the disk cooled and condensed so efficiently and so quickly that it was all used up in that single initial burst, leaving nothing behind. This one celestial object forces us to reconsider the entire life cycle of galaxies. The universe clearly has more than one way to silence a star factory, leaving behind beautiful, orderly, and utterly still monuments to a furious and forgotten youth. Galaxies spin with such ferocious speed that they should tear themselves apart. The outer stars are whipping around far too fast to be held in place by the gravity of all the visible matter, the stars and gas and dust we can see. Something else, something we cannot see, must be there, providing an immense invisible gravitational anchor. This is the ghost in the cosmic machine, dark matter. It does not emit, absorb, or reflect any light, making it completely transparent, yet its gravitational pull is the primary architect of the universe's large-scale structure. Then there is an even stranger force at work. In the late 1990s, astronomers made a discovery that shattered the prevailing view of the cosmos. They found that the expansion of the universe is not slowing down due to gravity, as everyone expected. It is accelerating, as if some repulsive force is stretching the very fabric of space itself. This mysterious driver was named dark energy, When you add up all the components of the cosmos, the result is humbling. The ordinary matter that makes up every star, planet, and living thing accounts for a mere 5% of the total universe. Dark matter makes up about 27%, an invisible scaffold guiding the growth of galaxies, but the lion's share, a staggering 68%, is dark energy, the force behind the accelerating expansion. Think of it like this: everything you have ever seen, touched, or known is just the faintest visible froth on the surface of a deep, dark, and mysterious ocean. We know dark matter exists because we can see its gravitational handiwork, bending light around galaxies in a phenomenon called gravitational lensing. But we have no idea what it is made of. It could be a sea of undiscovered particles that barely interact with normal matter. Dark energy is even more perplexing. Is it a property of empty space itself, a constant energy density woven into the vacuum, or is it a sign that our understanding of gravity, Einstein's theory of general relativity, is incomplete on the largest scales? This is the frontier of cosmology. The universe we see is a mere 5% of the story, and the remaining 95% is a profound mystery, the ultimate reminder that we are still just beginners reading the first page of a cosmic epic. That 95% of the unknown cosmos is a humbling thought, yet one of humanity's greatest achievements is far closer and surprisingly visible. You can look up on any clear evening and watch the International Space Station sail overhead with your own eyes. It appears not as a flickering point of light, but as a brilliantly steady, fast-moving star, gliding silently across the sky. It moves with a purposeful, unmistakable speed, completing a full journey from one horizon to the other in just a few minutes. This is not a distant satellite, it is a laboratory the size of a football field, hurtling around our planet at 28,000 kilometers per hour. At that incredible speed, the astronauts on board witness 16 sunrises and 16 sunsets every single day. To spot it yourself, you only need to know when and where to look. Websites and smartphone apps can provide precise timing alerts for your location, telling you when the station's orbit will bring it into your view. The best sightings occur just after sunset or just before sunrise, when the ground is in darkness but the station, flying high above, is still bathed in sunlight. It will appear brightened to a magnitude often rivaling Venus, and then seem to vanish as it flies into Earth's shadow. For the crew living inside that moving point of light, life is a constant balance between work and wonder. They conduct experiments in microgravity, maintain the station's complex systems, and spend hours each day exercising to counteract the muscle and bone loss that comes from living without weight. But they also spend their free time floating by the cupola, a giant window that offers a breathtaking panoramic view of our planet. From there, Earth is a vibrant, living canvas with no borders visible, just the brilliant blue of the oceans, the swirling white of the weather systems, and the delicate thin line of the atmosphere. To see the station pass overhead is to witness a home away from home, a tiny, bright testament to what we can build when we work together, sailing through the starry darkness just above our heads. Our own single sun feels like a universal standard, but star systems often prefer company. Far beyond our solar system, worlds exist with two suns in their sky, planets known as circumbinary planets. The most famous of these is the Kepler-16 system, where a cold, Saturn-sized planet orbits a pair of stars. These two stars are locked in a tight gravitational dance, whirling around each other every 41 days, while their shared planet makes a wider, slower circuit around them both. From the surface of such a world, the view would be utterly alien. The two suns would trace complex paths across the sky, sometimes setting separately to create a double sunset, and at other times eclipsing one another. Their light would cast multiple shifting shadows, a daily light show of celestial choreography. The formation of such a world defies our old assumptions. How can a planet coalesce from a disk of gas and dust when the central gravity is split between two competing stars? The chaotic environment should tear a forming planet apart. Astronomers believe the planet must have formed much farther out in the system, in a stable region beyond the immediate gravitational tug-of-war, and then slowly migrated inward to its present orbit. This discovery proves that planet formation is more robust and adaptable than we ever knew, capable of occurring even in these dynamically complex stellar households. The climate on such a world would be wildly unpredictable. With two sources of light and heat, The length of day and the intensity of sunlight would vary dramatically depending on the positions of the two stars. A planet in the habitable zone might experience seasons of extreme temperature swings, from periods of constant daylight when both suns are in the sky, to stretches of relative coolness when one star is eclipsed. Life there would have to be incredibly resilient, adapted to a sky ruled not by one steady sun, but by the ever-changing rhythm of a binary dance. The serene dance of binary suns is a local drama, but our entire galaxy is caught in a far grander and inescapable motion. Our Milky Way is hurtling directly toward the Andromeda Galaxy at a staggering 410,000 kilometers per hour. This is not a chance encounter, but a fated merger set to unfold in about 4.5 billion years. Imagine two majestic star cities, each containing hundreds of billions of suns, drawn together by their mutual gravity in the slowest, most graceful collision imaginable. From a hypothetical future Earth, the approach would be a breathtaking, multi-million-year spectacle. At first, Andromeda would appear as a small, fuzzy patch in the sky, much as it does today. But over eons, it would steadily grow, transforming from a faint smudge into a brilliant, sprawling pinwheel of light that eventually dominates the entire night. As the galaxies draw nearer, their mutual gravity begins to warp their structures, pulling out long, shimmering streams of stars in great tidal tails. The skies would fill with a celestial tapestry of unprecedented beauty, a constant evolving display of cosmic forces at work. The actual merger, when the two galactic cores finally swing past each other and begin their intricate dance, will be the most dramatic phase. Yet for all the violence of the process, the likelihood of any two stars colliding is almost zero. The distances between stars are so immense that the galaxies will pass through one another like two swarms of gnats, their stars sliding past in the vast emptiness. Our solar system, however, will almost certainly be flung into a new, wildly different orbit, carried far from its current suburban location into the outer reaches of the newly formed galaxy. The familiar spiral arms of the Milky Way will be utterly erased, and over the next 1 to 2 billion years, the two galaxies would settle into a single, large, elliptical galaxy, often nicknamed Milkomda. The night sky from that future world will be profoundly different, with a dense, diffuse glow of blended starlight replacing the crisp Milky Way band we know today. This cosmic union is not a destructive end, but a creative transformation, the next inevitable chapter in the life of our galactic home. The cosmic dance of galaxies is interrupted by a profound emptiness. Scattered across the universe are vast regions of nothingness known as cosmic voids, and the grandest of them all is the Boötes void. This is not just an empty patch of sky, it is a spherical chasm of staggering scale, a hole in the cosmic web so large that it spans 330 million light-years across. To grasp that immensity, picture our entire Milky Way galaxy, then imagine it as just a tiny speck. Now fill a sphere with thousands of galaxies. The Boötes void could easily hold thousands of such galactic collections, yet instead it contains almost nothing. Astronomers have found only about 60 galaxies in that entire, mind-numbing volume, where according to the average density of the universe, there should be tens of thousands. This is not merely empty space, it is a cosmic desert on a scale that defies human comprehension. How does such a void come to be? The leading theory points to the very foundations of the universe's structure. In the early cosmos, tiny fluctuations in density were amplified by gravity. The regions with slightly more matter pulled in more and more gas, eventually forming the great walls and filaments of the cosmic web. The regions with slightly less matter were left behind, their material slowly drained away by the gravitational pull of their denser neighbors. Over billions of years, these underdense regions expanded and merged, creating the vast voids we see today. The Boötes void is likely the result of several smaller voids merging into one ultimate emptiness. Another, more speculative idea involves the mysterious influence of dark energy. As the universe expands, dark energy pushes galaxies apart. In a void where the gravitational pull is already weak, dark energy's repulsive force may act more effectively, accelerating the expansion of nothingness itself and making the void grow even larger and emptier over time. This giant blank spot on the map is not a flaw in the cosmos, but a fundamental feature. It teaches us that the universe is not a uniform soup, but an intricate sponge of rich clusters and empty voids, and that sometimes the most telling structures are defined not by what is there, but by what is missing. The human heart, sculpted by a lifetime of gravity, subtly reshapes itself in the void. Without the constant pull to fight against, the heart muscle does not have to work as hard to pump blood throughout the body. Over months aboard the International Space Station, this reduced workload causes a remarkable physical transformation. The heart becomes more spherical. Studies using advanced ultrasound machines on astronauts have precisely measured this change, revealing a shift from the familiar elongated pear shape we know to a rounder, more ball-like form. Think of the heart as a balloon. On Earth, gravity pulls the blood downward, giving the heart a distinctive, slightly stretched shape as it works against that force. In microgravity, that pull vanishes and the blood distributes itself more evenly, allowing the heart to relax into a more symmetrical, spherical state. This is not merely a curiosity, it is a significant adaptation with real consequences. A more spherical heart can function less efficiently, and there is concern that this change could be linked to a condition known as cardiac atrophy, where the heart muscle actually weakens and loses mass from lack of consistent exercise. For astronauts embarking on a years-long journey to Mars, this presents a serious medical challenge. How do you keep a heart strong when it does not have to work hard every single day? The countermeasures are intense, involving rigorous daily exercise regimens on specialized equipment to simulate gravitational stress. Yet the spherical heart offers a gift to medical science back on Earth. By studying this extreme adaptation, researchers gain profound insights into how gravity and workload affect heart health for patients with debilitating conditions. Someone confined to long-term bed rest experiences a similar, though less dramatic, reduction in cardiac strain. Understanding how an astronaut's heart changes and recovers helps doctors develop better rehabilitation strategies for Earthbound patients, turning a problem of spaceflight into a solution for terrestrial medicine. Our most vital organ carries the imprint of the world we live in, and in leaving that world, it reveals secrets about its own fundamental nature. That breathtaking portrait of cosmic creation is already a ghost. The pillars of creation, immortalized by the Hubble Space Telescope, show three towering columns of cool dust and gas stretching light years long, with new stars igniting within their tips. They stand as a symbol of the universe's endless cycle of birth, yet evidence gathered from a different eye in the sky suggests this iconic structure has likely met a violent end. NASA's Spitzer Space Telescope, which observes in infrared light, detected a massive cloud of superheated dust surrounding the Eagle Nebula. The most plausible explanation for this scorching heat is a shockwave from a nearby supernova explosion that blasted through the region. The pillars, being relatively fragile structures of gas, would have been utterly vaporized by such a powerful wave of energy, eroded away like sandcastles before a tsunami. Here is the profound twist of cosmic time. The Eagle Nebula is about 7,000 light years away. The light Hubble captured, showing the pillars intact, left there 7,000 years ago. The evidence of their destruction from Spitzer would have taken another 7,000 years to reach us. We are seeing two different moments in a single glance, a before and an after separated by millennia. The destruction probably happened roughly 6,000 years ago, meaning we are watching a light show of a cataclysm that is already ancient history, a beautiful ruin we simply have not seen crumble yet. The universe reminds us that its most enduring images are often fleeting illusions, snapshots of a past that has long since transformed. Even as the Earth sails through the void, it is constantly gaining mass from a gentle, silent rain. Every year our planet collects roughly 40,000 tons of cosmic dust, a fine mist of extraterrestrial material that has been falling since the very beginning. This is not the dramatic, fiery arrival of a meteorite, but a continuous, microscopic drizzle. The source of this cosmic sediment is a celestial highway of debris left behind by comets and asteroids. As these objects travel through the solar system, they shed tiny particles in their wake. When Earth's orbit carries us through these dusty trails, our gravity pulls the particles in. They enter the atmosphere at high speeds, most burning up completely to become the faint, fleeting streaks we call meteors or shooting stars. But the smallest grains, some no larger than a speck of pollen, can survive the descent. They slow down in the upper atmosphere and drift for months or even years before finally settling on the surface. This means that the air you are breathing right now contains traces of stardust, and the thin film on your windowsill or car roof holds microscopic remnants of comets. Scientists collect this dust in some of the most pristine environments on Earth, like the Antarctic ice sheets and the deep ocean floor, where it can be separated from terrestrial contamination. Each grain is a time capsule, preserving the original, unaltered chemistry of the ancient solar system. This gentle accumulation has been happening for 4.5 billion years, contributing to the very ground beneath our feet. Our entire world is in part built from this ancient cosmic precipitation, a quiet gift from the void that continues to add to our world, one tiny particle at a time. From the gentle drift of our own moon to the silent, ghostly pull of dark matter, this journey through 30 cosmic truths reveals a universe far stranger and more wonderful than we often suppose. We have walked on a world where a day outlasts a year, discovered skies that rain glass, and learned that our planet grows heavier each year from a silent rain of stardust. We have seen storms that rage for centuries and diamond stars the size of planets. These are not just isolated curiosities, but pieces of a grander puzzle, a portrait of a cosmos that is dynamic, violent, and breathtakingly beautiful. It is a realm where the familiar is an illusion and the impossible is an everyday occurrence. This cosmic perspective is a powerful reminder of our own place, not as the center of everything, but as fortunate witnesses to a spectacular show. The universe is not just out there, it is a part of us, from the ancient cometary ice that may have seeded our oceans to the starlight that is a direct message from the past. Now we turn the conversation over to you. Of all these mind-bending facts, which one reshaped your view of the cosmos the most? Share your favorite space fact in the comments below. We would love to hear what captures your imagination. If you enjoyed this voyage to the stars, be sure to subscribe for more journeys to the edges of our understanding. The universe has countless more secrets waiting to be uncovered.